In this series of videos, we are going to discuss exception handling. When we write our code, we expect it to run in a particular way. We expect kind of everything to go according to plan and for the program to run smoothly and for everything to happen as we planned it to happen. However, sometimes there are unusual or erroneous, meaning wrong or incorrect, or unexpected situations that come up, and we have to write code and write our programs in a way that it can deal with those type of situations. The way we do that in Java is through exception handling. So exception handling is the type of approach we use to deal with these, unusual or incorrect or erroneous, unexpected situations. Now, in our code, when one of those things happens, when something unusual happens, the language that we use is we say that an exception is thrown, or you might also say that the code throws an exception. What we're going to do is we're going to learn how to add to our code, to put code in to deal with that happening. So we will account for those unusual things that could happen, and we will deal with those exceptions that are thrown. That's called handling the exception. So an exception is thrown, and then we write code that handles it. If an exception is thrown and we don't have any code to handle it, the program will crash. You most likely have seen this happen before at some point where you ran a program and it started to run and then something happened and the program crashed and you got that, red long stack trace spit out to you that you saw. Most likely you've seen that before. That is an exception being thrown, it not being handled, and thus crashing your program. So we're going to work on a little example to get us into this idea of exception handling. So we're just going to write some simple code to read in a positive number from the user. So I just have a little main method here. I'm going to create a scanner object. And I'm going to tell the user to enter in a positive number. And then I'm going to read the number from the user. And I'm going to use my integer.parseInt method where I pass in scan.nextLine. So this will read a string from the user. I will then parse that to be an integer. And of course, I need to import my scanner class so that I can use it. And then I'm just going to say, well, if that number is greater than 0, we'll just print yes. Otherwise, we will just print, sorry, that number is not positive. Okay, so simple little program designed to read in a positive number and then give some output. So if I run this and I type in, 5, it gives me a yes. If I type in, -1, it gives me a sorry, that number is not positive. This is how I expect things to go. However, if I run this program and me as the user, if I type in hello, my program crashes. So this is an example of an exception being thrown, but obviously I don't have any code in here to handle that exception because we haven't written that yet, so the program crashes. Okay. When the exception is thrown, you will get this stack trace printed out. What this stack trace shows you is it gives you some information about what went wrong. So it gives you the name of the exception. In this case, it's number format exception. It gives you a little message for input string hello. And it gives you a trace of where in the code it happened. So it says that it happened in number format exception. Sorry, actually, we'll start here at the bottom. It happened in exception practice line 9, right? So you can start at the bottom. We were in the main method of this exception practice class on line 9. If we go to that, it's that line there. And that makes sense because that makes sense that something bad happened there, right? Because we read in a string, tried to convert it to a number, but of course it's not a numeric string, right? It's the word hello. You can't convert that to a number. So that's where the error happened. So you start at the bottom and you trace up and you can tell in this particular example, that's really all we need to know is where in our own code. But it actually does tell you that the part of the code where the integer parseInt method was, where it tried to do that, and you can trace it back even further. So you can actually trace it into the Java API classes. But really what you need to know is where in my code that I just wrote did this error happen. And so that's why you kind of start from the bottom to see where it happened. So this is what will happen if an exception is thrown and we don't handle it. The program will crash. And again, this an exception is thrown because something unusual happens, right? We expect, if all goes according to plan, we expect the user to type in a number and then we evaluate that number. That's how our program should run. But things can happen that are unusual or erroneous or unexpected, and in this case that means the user typing in a word instead of a number. So how can we deal with this? Well, the most simple form of exception handling in Java is the try-catch block. So the basic way to handle is with a try-catch block. There is a try block and a catch block. The try block contains all the code for your algorithm. So this is basically the code that you want to run if everything goes smoothly and according to plan. All right, it's called a try block because, the Java virtual machine will try to run all the code in there. And if everything goes as you expect it to, it will be able to run all the code in there. But there also might be code in there that could throw an exception. So that code in your try block is everything that should run correctly, but could also show a problem. Okay, so that's what we put in the try block. Now, what happens is when you run the code and a statement inside that try block does throw an exception, the execution of your program stops. It gets put on pause. And the JVM, the Java Virtual Machine, it looks for some code that will tell it what to do in response to that exception. It's saying, okay, something strange happened, an exception was thrown, I'm going to stop what I'm doing, and I need to find code that tells me how to react. When we, the programmers, write that code, we put it inside of a catch block. So the catch block is going to contain code that tells our program what to do if this situation happens. So this is the basic general setup of a try-catch block. So we have the keyword try, open bracket. In here goes all the code that we want to execute if all goes according to plan. It also contains that code that might generate some erroneous situation, so that might throw an exception. We close that bracket, and then we have the keyword catch. Catch takes in a parameter. So this looks like a parameter of a method, only it's not a method, it's a catch block, but it takes in one parameter. It's an object, so that's its type, and that's the name of the parameter. And then we've got open bracket, close bracket, and in here we put the code of what we want our program to do if that exception is thrown. So we've got our keywords or reserved words here, try and catch. This here is our catch block parameter. This is an exception object. So in Java, remember that all variables are either primitives or objects. Well, exceptions are no different. An exception is an object. So when this unusual event happens, like in our example, when the user types hello, an exception is thrown. What that means is that an actual object is created. That object represents the exception. So the exception event is an object in Java. It has a data type. It comes from it's a type of a certain class. It's an object. Okay. Now, just like all other objects, that object has information in it, right? It has instance data variables. So in particular, exceptions have the type of event. So kind of what was the nature of what went wrong. It'll have some sort of message that hopefully gives you a description of what happened. And then it'll also have information about where that event occurred. What line of the code were you at when this happened? So the exception actually is the object. And again, we can see that here in the catch block. So this is the object. We give it a type and a name so that we can refer to it just like we would a formal parameter in a method. It's very similar to that. The difference is just that this isn't a method, it's a catch block, but it still takes in an object parameter, and that represents our exception. So when that exception is thrown, it's as if behind the scenes you have this line here. So let's say the class of our exception is exception type. In the example we just looked at, the class was number format exception. Okay, so that's an example of an exception class. Just for these slides, I'm just saying exception type is some made up type of exception. So when that erroneous event happens, when that unusual event happens, what happens is it's as if the code says throw, which is a new keyword that we're seeing. New, remember the new operator means we're creating some sort of object, and we're creating an object of that exception type. And then we're sending in some string that describes what happened. So you don't actually see this code. It's happening behind the scenes, but this is what's going on. You are creating, with this part here, you're creating a new exception object, just like you would with any other object, with a call to the new keyword, call to the constructor, and sending in actual parameters. And then we just introduce this new throw word, which what that means is it says, okay, take this exception object and start looking for how to handle it. So start looking for a catch block that's going to tell you how to react to an exception of this particular type. So our exception objects, again, they're objects. They have a string instance data that contains a message, usually describes something about the reason of why the exception was thrown. You can get this message by accessing a getter method, get message. So in my parameter, I called my exception EX. You'll often also see it called described as just E. Of course, you can name it anything, but conventionally you'll see E or EX. And you can get the exception message by invoking EX.getMessage. you can also print a stack trace to see where the error came from. So you do that by saying ex.print stack trace. And that stack trace, when you invoke that method, will give you what we saw here. This is called a stack trace. It's a trace of where you were and where you came from, how you got there, right? So we were in main. Main invoked a method from integer, which apparently invoked another helper method from integer, okay, and so forth. So this will give you the stack trace. If you want to access that at any time with an exception, you just invoke print stack trace. Now I should note that typically we print out a stack trace when we are testing. This often isn't left in the program when we expect a user to use it. So stack trace is really useful for debugging and for us to figure out what's going on. It's not typically left in the program to show a user, because someone using our code, in theory, doesn't really care where the exception or the error happened. They just want to know what to do about it. So let's go back to our try catch block. So this is again our try block. Starts with the keyword try. All of the code in between the try curly brackets is the code that we expect to happen, to execute if all goes well. This is sometimes called the normal execution flow. So this is what we expect to happen. Okay, all of the code inside these brackets. That's the try block code. In addition to this being the code that we expect to run properly, this is also the code that contains some statement that at some point might throw an exception. If that exception is thrown, the execution of the try block stops. We just pause. We pause the execution and we start looking for a matching catch block. So control is passed out of the try block and into the catch block. When we find a catch block, if we find that the exception type that was thrown matches the exception type that's a parameter, if they're the same type, then what we do is we execute all of the code in the catch block, and that'll be all the code in between the curly brackets. So that is the code that responds to the exception that was thrown. Now, this code will only be executed if it's the right type. There's lots of different types of exceptions, just like there's lots of different classes in Java. So when an exception is thrown, the JVM looks for a catch block that's the right type. It has to match the type. If not, it keeps on looking. Okay. Once it finds a match, then that actual exception object is passed into the catch block. And we do that so that we can use it inside the catch block. Perhaps inside the catch block, we want to print that stack trace, or we want to get the message, or we want to know some other information about the exception. We do that by invoking methods on that object. After the catch block is done, we then pick up with whatever code comes next, comes after the try catch block. Now, really, really important thing and kind of common error that I see, it's important and critical to know that we never go back up into the try block. So let's say the try block has, 5 lines of code. We execute the first just fine, execute the second just fine, and then in the third line of code, the exception is thrown. The execution pauses, we jump down to the catch block, if it's a matching exception type, we execute the code in the catch block, and when that's done, we just move on to after the try catch block. We will never return and finish the code that was missed in the try block. So once that exception is thrown, control leaves the try block and it never returns. We do not come back. So that's a really critical thing to understand about setting up these try catch blocks. So let's set up a simple try catch block so we can handle the erroneous situation of a user not entering in a number. And what we want to do is we want to provide a message to let our program end gracefully. So it is possible that when an error situation arises, you actually do want to end your program. Perhaps there is no way that you can continue with what you need to do. But you want to end what's called gracefully, meaning you don't want the program to just crash with printing out a stack trace. You want it to end in some way that you describe. So what we're going to do is we're going to first start our try block, and I'm going to put all the code that I expect to happen. If all goes according to plan, I'm going to put it inside of a try. So there's my keyword try, there's my open bracket, and I'm just going to put all this code in it, and there's my close bracket. Now, you might put the scanner in your try block. You might put the try block starting here instead of here. It's somewhat subjective exactly what code belongs before the try block and exactly what code belongs in the try block. The idea is to encapsulate all the code that kind of goes together to accomplish the task. Okay, that's the idea of how you group together a try block. You want to avoid having try blocks surround just single lines of code usually, but you usually also want to avoid having a try block surround your entire program. So it takes some practice to kind of get used to it. But the general idea is to, put the code that represents one particular task or one particular, approach or something like that, the code that's related to each other, group that together inside the try block. Now, once I have my try block, I'm going to write a catch block. There's my keyword catch, and then the catch block takes one parameter, and I'm going to catch exceptions of type number format exception, and I'm going to call that parameter EX, and then I'm going to open close my catch block. Now I'm in Eclipse, so I'm going to use Control-Shift-F to update all my indenting, and that's what my simple try catch looks like. So what I can do is I can just have a printout. Sorry, that is not a number. So if I run this and I again enter in just a number 4, it's going to say yes. Number -1, it's still going to say that number is not positive. But now if I enter in hello, it says, sorry, that's not a number. It got to this point in the code, an exception was thrown. We started looking for a match to the type. We know from the previous stack trace that the type is number format exception. We also can determine what the type is by looking at this method, which we'll look at in a moment. And so we find this catch block, we execute the code that's there, and then we move on, which in this case, there's nothing after the try catch block, but I could put, goodbye. Okay. So that's how it works. That's a basic way that we can account for that unexpected situation. In this case, the point of my program is just to test if the number is positive or negative. I can't do that if the user doesn't enter in a number, so I'm just going to end the program. The program is done. And note that after that exception was thrown and we moved down into the catch block, we never executed this. So if I put a printout here, and if I type in hello, we will never see that I read that number because we never return back up to the try block. After the exception is thrown here, we jump down to the catch. After the code and the catch executes, we just jump down to after the whole try catch block and we move on. Now inside of our catch block, we might also print out the message. So let's see, we can get the message. Let's see what the message is. So the message here is for input string hello. That gives us some information. Hey, there was an input string here that didn't work out so well, okay, that gave a number format exception. We could, if we wanted to, also print the stack trace. And that will show us the same thing that we showed before when we didn't have the exception handling in there. It shows the trace of where the exception came from, okay? Again, this is typically used for when you're debugging your own code and trying to track down errors. It's often then not left in there for the final program that you would show a user, because you would just want a user to see this, hey, that's not a number message. You wouldn't want them to see all this stuff about where the error happened. That's not what they need to know. They just need to know, hey, you didn't give me a number. Okay, so there is your first example of a just very simple try catch block.